Hello.
Hello,
Hi, how are you?
I'm good, and you?
I'm also good. I think your name is Destiny.
Yes, I'm Destiny.
Okay, great. What a name. Beautiful. All right. So
Okay.
I had given you the SAT mini diagnostic. Did you got some time to check it out, maybe?
No, I have not been able to check it out yet.
All right, no problem. What we can do here, will start that thing. We'll start the diagnostics. And
Okay.
because we have only 1 month here for the SAT, and you have given the
Mhm.
ACT before, right?
Yes, I have taken the ACT.
And your score was 21.
I believe so. I'm not exactly sure.
Okay. Actually, 21 means nearly 1080 out of 1600 in SAT, a type nearly. So it's a little above than the average. So we need to be a little more, focused
Hmm.
on increasing it more than average, like it should be, because what I felt from your, like, from the talk of with your mom, that
Hmm.
you are able to grasp the things, you're a good student. So so
Hmm.
let's have the focus on the top 98 percentile, 99 percentile, if not the perfect score, but at least closer to that. And for that
Hmm.
we have to be a little more focused, a little more, because I'll be giving you so many things here. Maybe I'll be giving you so many strategies and so many concepts. You need to have some pen and paper so that you can
Yes.
write it down, and then you can revise it, and then you can use it again and again.
Okay.
What happens most of the times when I give some strategies and everything, then the student learns that, but when when he or she doesn't use it again and again, then it gets lost. And when the question comes again and we need to use the strategy, they they don't use it because they are not used to it. They're not, like, they're not,
Yes. Yes.
they have, like, forgotten that. So that should not be the case. Otherwise, the score will not increase much. All right, so let's get started, because I'll be giving you the concepts also, if needed, at some point. It might take more time, obviously, while solving a question. Will not be focusing on solving the question. We'll be focusing on all the concepts which are related to that question, and all the strategies which we need for that question, right?
Yep.
Right. Otherwise, if we would be having like 2 months, if we'll be having like maybe 8 to 10 sessions, then we could have use the drills, like heart of algebra drills, passport advanced maths, all the 4 portions of the SAT, and we could
Hmm.
have done all the questions related with that, and then use the test papers and see what could be done. But no problem in that. We can go with the test paper, and we can understand the concepts, and we can apply them as they will be coming in the next few sessions, in the next few.
Okay.
Yeah.
This is actually the first time I'm taking SAT, but I can like retake it. So I'll probably do more sessions, like
Oh,
depending on how that score comes in.
beautiful. Great. Um, that's great. So we'll be focusing on the SAT test papers in this month, and the concepts related with that. What do you think? Like, is it okay?
Yes, that's fine.
Hmm. So question number one, are you able to see that?
Yes.
What you will do here, how will you try it? Like, what is your
Oh,
approach of doing it? Yeah.
so I would say you would multiply 3 times x and then 3 times -4.
Mm-hmm.
So that would be 3x minus 12. And then you would add the 12
Mm-hmm.
from that one side to the 42.
Okay.
And then you would divide the 54 by 3.
Okay. Yeah, that's right. 54 divided by 3 is how much?
54 divided by 3 is
Because sometimes you'll be having a no calculator portion. It's not ACT. In the ACT, you can use the calculator, for all the questions, but here you'll be having two portions. There's one no calculator portion, and the other one is calculator portion. So in no calculator portion, you cannot use the calculator.
Okay.
So it depends like on your college, like on your like where you're going. If they're accepting the ACT and you're comfortable with more calculations, trigonometry, all those things, then it'll be definitely preferable to go for the ACT again. If they are accepting the SAT, then you need to be more focused on more the concepts, more equations, solving them without using the calculator, and the calculations without the calculator, but little bit,
Okay.
not much, but little bit. So then that'll be for the SAT. All right, so
Okay.
54 divided by 3 is how much?
18.
18. So which option?
C.
All right. So see, I'll give you one strategy. It's not meant for only this question. It's meant for all of the questions which are having the variable which we need to solve and the answers for that variable in the options. So the strategy is, you can write it somewhere. If you're having variables in the questions and
Okay.
the answer in the options, plug it in.
Okay.
Okay, so plug it in. You can remember it by this sentence, this word. So plug it in. So well, this is easy for solving also. We can solve it very easily. So you don't need to plug in, but there will be some questions where the equation will be a little bit more complicated, and there'll be solutions. There'll be the value of x will be given in the options. At that time, it's always preferable to plug in the answer and see which one is working.
Okay.
All right. So this is the
Yes.
first strategy. This is the first thing which you can apply for all the questions where you're having the variable in the question and the answers in the options.
Okay.
Right. So plug it in. So what I will do here, I'll not take my pen and paper. I'll just see it, and I'll plug in 4 here. It's 4 minus 4, that's 0. 42 is not equal to 0, so not the 4. 10 minus 4 is 6. 6 times 3 is 18. No. 18 minus 4 is how much?
14.
14. 14 times 3, 28, 38, 42. Yeah, that's right. Done. I don't need to even take the paper and the pen for solving it. So I can save a few more seconds, because there'll be some questions in the SAT at the end where you need little more time than the average. So that's why the more faster you do the easier ones, the more time you will get for the the difficult ones.
Yes. Yes.
So plug it in, right?
Yes.
All right, so let's go to the second question. So can you read it?
For what value of k does x squared plus kx plus 9 equal x plus 3 squared?
So what you will do here?
So for this, would you distribute the squared for the x and the 3 or no?
It's not like distributing two, like it's not like 2 times x plus 3 equals
Okay.
2x plus 6. It's like it's x plus 3 whole squared. What do you mean by 3 squared?
9.
3 times 3, right? 9.
Yep.
And what do you mean by x squared?
X times x.
In the same way, x plus 3 whole squared will be x plus 3 times
X times x plus 3.
exactly. So the square is on x plus 3, so that means it is to be multiplied 2 times. So x plus 3 times x plus 3, and you need to solve it, right? So x plus 3 times x plus 3. Can you solve it? Can you distribute it now?
Yes. X plus 3. X plus 3.
How do you distribute?
That you would first do x times x, which would be x squared.
You can FOIL, yeah.
X x times 3, which will be plus 3x,
Mm-hmm.
then plus 3x again, because 3 times x, and then plus 9, because 3
Mm-hmm.
times 3.
Can you combine any like terms?
So that would be x squared plus 6x plus 9.
Correct. So x squared plus 6x plus 9. So this on the right side is actually, x squared plus 6x plus 9. And this is equal to x squared plus kx plus 9. Now,
Oh, okay.
right now, if you're having ax squared plus bx plus c, and that is equal to 2x squared plus 3x plus 4, how much will be a?
2,
How much will be b?
3,
And how much will be c?
4.
That means you're comparing the coefficients of x squared and x and the constant. So coefficient of x squared is equal to each other. A is 2. Coefficient of x, that's b, is equal to coefficient of x, that's 3. And the constant c is equal to the constant 4. In the same way, x squared is here, x squared is here. We don't have to care about x squared, we have to care about k. So k is the coefficient of x. What is the coefficient of x here?
6.
So k is 6, that's it.
Okay.
Right?
Yep.
Okay. And here also you can plug in the value of k as 6 and see, because when you'll be plugging in, but that will not be much fruitful, like, because you have to compare the things. But here I'm gonna tell you one more thing, which you may not need here, or which you can apply here, is the 3 identities. Very, very important. They are used in almost every SAT test paper. The first identity is, if you're having something like a plus b whole squared, like a and b can be anything, like 2x and 4y, x and 3, x and y, anything. So if you're having something like a plus b whole squared, you can write it as a squared plus 2ab, sorry, I written x squared, a squared plus 2ab plus b squared. This is always correct. For example, if you're having 2x plus 3y whole squared, then you can write it as, this is actually a and this is actually b. So a plus b whole squared, you can write as a squared, that means 2x whole squared, plus 2 times ab, so 2 times a is 2x, b is 3y, plus b squared is 3y whole squared. So that'll be 2x whole squared. Now we can give the square to everything, like 2 as well as x. It'll be 4x squared plus 2 times 3 is how much?
2 times 2 is 12.
12xy plus 3y whole squared will be how much?
9.
9y squared. So 2x plus 3y whole squared is actually 4x squared plus 12xy plus 9y squared.
Okay.
Right? So remember this thing, a plus b whole squared is equal to a squared plus 2ab plus b squared. Now, how can you use this here? Because we know that a is x and b is 3. So you can write directly a squared, that is x squared, plus 2ab means 2 times x times 3 plus b squared. B squared is 3 squared, that's 9. So you can write as x squared plus 6x plus 9. You can still save a few more seconds.
Okay.
That's it. So you need only one step here, if you know the identity. But maybe this might not be much useful in this question, but it'll be very useful in other questions as well. So x plus 3 whole squared, you can use the identity a plus b whole squared is a squared plus 2ab plus b squared, right? And the second one is a minus b whole squared. That is equal to, this 2ab, this is only negative, everything is same, a squared plus b squared minus 2ab.
Okay.
So a minus b whole squared is a squared minus 2ab plus b squared. Or you can say a squared plus b squared minus 2ab. One of the same thing. You can put the terms here and there, no problem. And the third one, which is used most often, is a squared minus b squared. And that is equal to a plus b times A minus B, or A minus B times A plus B. Very important, which is used most often. Third one.
Okay.
A squared minus B squared is A plus B times A minus B. So use the identities wherever possible. So you can write it. You can write these identities, A, 1, 2, 3. So use the identities wherever possible. So A squared minus B squared is A plus B times A minus B. Now, can you tell me what is the value of the, like, X squared minus Y squared?
That will be x plus y and then times x minus y.
Right, it'll be X plus Y times X minus Y. Or sometimes you'll be having this thing. Then you need to do the FOIL, and you'll end up at this point. So you can directly write this thing. You know, it's
Okay.
like the, you know, any one side can be given. If sometimes on the right side is given and you have to convert it into the left side.
Oh,
Right.
okay.
Yeah, because that at that time a person gets stuck. Like, how can I make this thing like this? So it's simply using the identity. A squared plus 2ab plus b squared, or a squared plus b squared plus 2ab is equal to a plus b whole squared, and a squared plus b squared minus 2ab is equal to a minus b whole squared, and a plus b times a minus b is a squared minus b squared.
Okay.
Did you wrote it somewhere?
Yep, I wrote it down.
Okay, great. So this is question number 2, and we learned maybe 1 or 2 strategies also. Let's move to the third one. And you know, there are certain questions where you're having some paragraph, like, you know, there are a few lines written, and if you it's like the English thing here. So at that time, don't read the whole question in one go. Read 1 or 2 lines, understand it, move on to the next 1 or 2 lines, understand it, take the information from that, and move on in that way.
Okay.
It's not like, you know, rushing through that, like going from top to the bottom, and then at the end you feel like, what, I had to calculate what was given.
Yeah.
So at that time a person has to read it again. So why not to read it in the first instance in such a way that you will be taking the information also and you'll be solving it also. So can you read question number 3?
A barrel of crude oil is extracted from a shale at a cost of $51 and then transported to and from the refinery at a cost of $6 each direction.
Stop. So what is happening here till now?
So a barrel of crude oil is extracted from a shale at a cost of $51.
Okay, so we have extracted the barrel of crude oil, and how much we have, like, spent?
$51.
$51. Okay, so my spending is $51, and what happened after this?
And then transported to and from refinery at a cost of $6 each direction.
Oh, so how much I have to add more, like, to my spending?
So it'd be $6 each direction.
How much would that be?
$12.
Exactly, because you're sending it to the refinery and then taking it back. So $6, sending $6, taking it back. So it'll be $12. So 51 plus 12 is my total cost now. 51 plus 12 is how much?
63.
Okay, till now I have spent 63 on this barrel of crude oil, and then
Oil is processed 3 times at the refinery plant at a cost of $9 each time.
now there's a processing, and it's processed 3 times. So like, what's the cost for the one processing?
$9.
So how many times it is processed?
3.
So how much will be the total?
$27.
So don't we have to add 27 with that previous spending?
27. That will be 90.
So you have spent a total of 90, right? Till now. Okay, so we have spent a total of 90, and then can you read the question now?
What is the profit in dollars per barrel if 1 barrel is sold for $93?
So what's the profit?
$3.
Right,
So 60.
done. Saving the time also and understanding the question in one go. in step-by-step method. All right. So option C. Let's move to question number 4, right?
Mhm.
Okay, can you read it?
The square above the square above has an area of 100. If Q is the midpoint of AC and R is the midpoint of BD, what is the area of the shaded area?
So we need to read the question step by step. Square has an area of 100. What does that mean? Is there any information hidden in that? If
That
I'm
means
Mhm.
that means the whole inside of the square is 100.
Okay, whole inside is 100, but what about the sides?
Mm,
What do you mean by area of the square? How much will be the formula for what is the formula for the area of the square? Any idea? Like how do you calculate the area of the square?
would that be length times width?
Yeah, that'll be same as the area of the rectangle, length times width. But square is having same length, same width, same length. It's like, for example, if the length is A and the width is A, then the area of the square is A times A. That'll be A squared.
Okay.
Are you understanding?
Yep.
So A squared is 100. So how much will be each side?
Would that be
Mhm.
well each side would be oh wait no.
Which number you can multiply with itself to get 100?
Oh, 10 times 10.
Yeah, or else you can do
Oh,
the square root here, square root A square, square root 100. So square root of A square is A and square root of 100 is 10. So
okay.
each side is 10. Because the area of the square is A squared. Remember, you can write the formula. Area of square is equal to side squared. If the side is A, it's A squared.
Okay.
And we know that the area of the rectangle is length times width, right?
Mm-hmm.
Okay, so the area of the rectangle is length times width. Area of the square is A times A, that's A squared. And we are given that the area is 100, that means each side is 10. Is it okay till
Okay.
now?
Yep. Doing good.
Okay, and what's the next information given in the question?
If Q is the midpoint of
Oh,
AC,
okay, we'll stop. We have to stop it here. Q is the midpoint. If Q is the midpoint, then what is AQ and what is QC?
AQ would be 5 and
And
then QC would
QC?
be 5.
Okay, so don't you see the triangle here, QCD?
Oh yeah.
How much is the area of this?
That would that be 5 times 10 divided by 2?
Correct, yes.
Oh, so that would be 25.
Isn't the same triangle on the top?
Yep.
Isn't the area here also 25?
Yep.
Okay, so okay, so because R is also the midpoint of BD. And what is the area of the shaded area?
So that would be 50.
Correct, because the total area of the square is 100 minus these two 25s, minus 50, and that's equal to 50, right?
Yep.
Option B.
Oh, that's pretty easy.
Okay, great. So till now, everything is fine, right?
Yep.
Let's move to the next one. Question number 5. Can you read it?
Ooh. The fraction is something I kind of struggle on.
The fashion?
Yeah.
Fashion, right?
Yeah, fractions.
Oh, fractions. I was listing fashion. Okay. We'll clear all these fractions, no problem.
Okay.
Let us first try to read this.
So 2x over x minus 1
Don't read it.
minus 3.
Don't read it. Just read the question.
Oh, which of the following expressions is equivalent to the expression above?
All right, so we're having some expression on the top and we want to simplify it and see what value we can get from the above fraction, combination of these fractions. So before going for the fractions, let's try to have the simple understanding of the fractions. As you multiply the numbers, for example, 2 times 3, you know that 2 times 3 is 6. All right.
Mhm.
In the same way, you can multiply the fractions. 2 over 3 times 4 over 5. You can multiply the numerator with the numerator and denominator with the denominator. So when multiplying the fractions, you will multiply numerator with the numerator. 2 times 4, that's 8, divided by 3 times 5, that's 15.
Okay.
First thing, multiplying the numerator, multiplying the fractions. So if you want to multiply the fractions, multiply their numerators and multiply their denominators. That's it.
Okay.
If you're having negative 2 over 3 multiplied by negative 7 over 8, how much will that be?
That would be negative 14 over 24.
Negative 2 times negative 7 will be?
Oh, 14 over 24.
Correct. And then you can simplify it because 14 is divisible by 2 and 24 is also divisible by 2. So 2 times 7, 2 times 12. So it'll be 7 over 12.
Okay.
Is it okay till now?
Yep.
Do you know, like, is it fine if we simplify this here?
Yeah.
Okay.
Yeah, I understand.
Okay, great. So this was the multiplication of fractions. Now let us see second thing, division of fractions. If you're having 2 divided by 3, and that is divided by 4 divided by 5. So division of the fractions is exactly the multiplication, but doing the reciprocal of the denominator. This can be written as 2 over 3 times, not 4 over 5, but 5 over 4. This and this is exactly the same thing.
Okay.
So it'll be 2 times 5 is 10, divided by 3 times 4 is 12. So it'll be 5 over 6.
Okay.
Okay, till now?
Yep.
What about 2x over 4 divided by 3y over 8? How much will that be?
So 2x over 4 divided by 3y over 8. That'll be 2x over 4 times 8 over 3y. That'll be 16x over 12y.
Correct. Can you simplify 16 and 12?
Yep, that'll be 4x over 2y.
2y? 4 times 3, 4 times 4. 4x over 3y.
Oh, 4x over 3y, yeah.
Right, because 4 times 4 is 16 and 4 times 3 is 12. So it'll be 4x over 3y. That's correct. So dividing the fractions is exactly multiplying them, but making the denominator the reciprocal thing here. That's it.
Okay.
Right? Now
Yep.
there comes, multiplying and dividing is a little bit easier. Now comes the addition and subtraction of the fractions. So 2 over 3 plus 4 over 5. So whenever you have to add the fractions, you have to always make the denominators same in any way.
Okay.
So this is 3 here and this is 5 here. Well, see the least common multiple of 3 and 5. 3 goes in 15 and 5 goes in 15. So because, a 3 and 5, 3 times 5 is 15. You can do that also. So
Okay.
let's make this 3 as 15. So we need to do that. We need to do multiplication of 5 here. So 3 times 5. But whatever you do to the denominator, you have to do exactly the same thing to the numerator.
Oh, okay, okay.
So that when you will cancel it, 5 and 5, you will get back 2 over 3.
Okay.
So multiplying by 5, multiplying by 5. What you'll multiply to 5 here on the right side? To make it
Yes.
same, 15.
3.
5 times 3, and then do same thing with this. So what is
Okay.
2 times 5?
10.
10 over 15 plus 4 times 3.
Will be 12 over 15.
12 over 15. Now the fraction, now the denominator is same. You can add the numerators and keep the denominator as it is. You can keep the denominator 15 and add the numerators. 10 plus 12 is how much?
22.
That's it. So this is the answer to the sum of these two.
Okay.
So 22 over 15. Now let's try one more. 5 over 9 minus 3 over 7.
5 over 9 minus 3 over 7. So that
Mhm.
means 9 times 7, which is 63. So
Mhm.
that would be 5 times 7 is 45
Mhm.
over 63.
Mhm.
Then minus 3 times 9, which would
Mhm.
be 27
Mhm.
over 63.
Mhm.
Then 45 minus 27 is 15.
Are you sure?
45 minus 27. Um, oh no, it would
Oh,
be 18
18, yeah, okay.
over 63.
Correct. Can you simplify this thing?
18 divided by
If you want to check that whether 18 or 63 is divisible by 3, then add the numbers. 1 plus 8 is 9. If 9 is divisible by 3, then 18 is also divisible by 3. 6 plus 3 is 9. If that is divisible by 3, then 63 is also divisible by 3.
Okay. So I mean, it would be 2 over 7.
Oh, okay. 9 times 2 and 9 times 7. So 2 over 7. That's right. So you have
Okay.
done it perfectly. Now these were the numbers. Now the problem occurs when there'll be variables. You're having 2x over 7y plus 3x over 9y, not 9, yeah, 9 only.
Okay.
Or I can make it a little bit easier, just 7 only here. What you
Okay.
will do?
Will we have to multiply the 7 by itself to y?
Exactly.
Okay.
So easy. We'll multiply 7 here with y and also with the denominator, right?
Mm-hmm.
And done. So it'll be 2x
Okay.
plus 3xy divided by 7y, right?
Oh, okay. Yep.
Now let's see the question. If you're having 2x over x minus 1, okay, and then they're having minus 3x over x plus 1. So this is now the term x minus 1, x plus 1. But how can we make the denominator same?
You could. Does it matter like whether you multiply the first one or the second one, or you can multiply either one?
You have to multiply actually both with something to make the denominator same, because if what you'll multiply with x minus 1 to make it x plus 1, you cannot do that. You have to like you have to multiply x plus 1 here and x minus 1 here,
Oh. Okay.
right? So that the denominators will be same. See, x plus 1 times x minus 1, x plus 1 times x minus 1. So now the
Oh, okay.
denominator is same, right?
Mm-hmm.
And now on the top, how much will it be?
It would be 2x squared plus 2x
Yeah, 2x squared plus 2x, and then
minus 3x squared
mhm, and
plus
then
3x.
correct, plus 3x, right? So how much will it be? How much is 2x squared minus 3x squared? Because you can combine the like terms.
That'll be negative x squared,
And how much is 2x plus 3x?
5x.
Divided by x plus 1 times x minus 1. Which identity is this?
Oh, that is the a plus b times a minus b.
Exactly. How much is that?
That's a squared minus b squared.
Correct. So what I will write here?
You would write x squared minus
1 squared, right? B squared is 1 squared.
oh 1 squared.
1 squared is
Okay.
1.
Oh, so x squared minus 1.
That's the answer. Any
Okay.
option here?
So that would be a.
A?
Oh no, a is negative. Oh
But
no.
you're having in the numerator, you're having negative x squared plus 5x. Or even you can write it as 5x minus x squared. It's one and the same thing.
Oh, it would be v.
Yeah, it'll be
Okay.
b. 5x minus x squared. Or negative x squared plus 5x. It's one and the same thing, right? So option B is the right answer. But I will give you the strategy here. This is the conventional way. This is the, all the students will do this, like those who know how to do it, they will do it like this. And if they know the identity, they can probably get a little faster. And if they know how to add or subtract the fractions in the variables, then they can probably get the answer here. But we don't need to even do all these things. What we'll do here, we'll use a strategy, and that strategy is this is the third one, I think. If you're having variables in the question and the variables in the answers, the answers are also in variables. The question is also having variables. Then make it real. What do you mean by make it real? Yourself select some number for x. Don't keep it in variables. Make it a real thing. So,
Oh, okay.
right, make it a real thing. Just put some number for x in the question and that same number in the options and see which one is working.
Oh, okay.
So, but you have to be a little bit clever here. You don't have to put in those numbers which are not acceptable. For example, you cannot put 1 because if you'll put 1, you'll be having 2x divided by 0. And anything divided by 0 will be, indeterminate or not defined. So you have to put a little bit that number which you can, like which is reasonable. So which number you want to put here? Any number.
5.
Okay, but I would definitely prefer the smaller numbers because they will be taking lesser time in solving, right? Okay, but
Okay.
we'll take 5. We'll take 5.
Okay.
So 2 times 5 will be 10, right? Divided by 5 minus 1 is 4. Minus 3 times 5 is 15. Divided by 5 plus 1 is 6. So our job is, reduced a lot. 2 times 2, 2 times 5, it'll be 5 over 2 minus 3 times 2 and 3 times
5.
Oh, 5 over 2 minus 5 over 2. We should get 0 in the answer when you plug in the value of x is 5. Good number. You understand?
Okay.
So you have plugged in x equals 5. You got the question as 0. That means when you plug in x equals 5 in option A, B, C, and D, you should get 0. Where you will get 0, that will be the answer.
Okay.
Let's try in here, the first option.
So negative 5 over 5 squared minus 1.
It's obviously not 0, right?
Yeah, it's not obviously not 0. Yeah.
So why to waste time in solving it? Second one.
Yeah, that would be 0.
Because 5 times 5 is 25. 25 minus 5 squared is 25. Wow, 0 divided by something. Anything is there. We don't care because 0 divided by anything is 0. That's done.
Yep.
and whatever the values, if you put the value of x is 5 in C and D, you will still not get 0 here and here. You'll get only for B, and that's it. Done.
Okay.
So what's the strategy?
Make it real.
Make it real. When?
And then you plug in any number.
Yeah, but when you'll make it real, what should be the question like?
You would just do 2 times like any number. And then plug it into the answer or
But
the answer.
when you'll be having the variables in the question and the variables in the answers, then only you can do the strategy, right?
Mm-hmm.
So variables in the questions and the variables in the answers, then make it real.
Okay.
What was the first strategy when you're having variables in the question and the numbers in the answers?
To plug it in.
Exactly, great. Now let's move to the next one. All right, do you know anything about absolute value equations?
Not really.
Okay, so this is a whole new concept. There's so many things here. Let's understand them, and then we can move to the sixth question.
Okay.
So we know if we're having an equation, for example, 2x minus 3 equals 4, in order to solve it, we'll just do adding 3 to both sides. You'll get 2x equals 7 dividing by 2. You'll get x equals 7 divided by 2. That's 3.5, right?
Mm-hmm.
But if the question is 2x minus 3, absolute value of that is equal to 4. So here, the thing is, absolute value is actually making all the negatives. If you're having anything negative inside, it'll make it positive.
Oh, okay.
Right? Because absolute value is going to give you the distance. For example, if you're having -9 here on the number line, and you want to calculate the absolute value of -9, that means you want to calculate the distance from 0 to 9. It's actually 9. That's it. So that's why absolute value of -9 will also be 9. Absolute value of 9 will also be 9, right?
Mm-hmm.
Absolute value of -23 will be 23.
Oh, okay.
So all the negative numbers, it makes it positive, right?
Mm-hmm.
That means if I'm telling you absolute value of something will be negative, is that possible?
No.
No. That means the first thing which you will write is absolute value of anything can never ever be negative. If this condition arises, if this question comes, because that was one of the questions in the SAT, there was some equation given here. For example, it was like absolute value of x minus 1 is equal to -2. What is the value of x? And the fourth option was there's no such value for x, and that was the answer.
Oh, okay.
Right?
Cool.
Because absolute value of anything can never ever be negative. So not will not solve it. It's not possible.
Okay.
No such value. Okay.
Yep.
So this is the first thing. Absolute value of anything can never be negative. Now the second thing, if it is positive here, absolute value of 2x minus 3, if that is positive 4, then we will solve it. We'll make two equations always. In case of absolute value equations or absolute value inequalities, we'll always make two things, two equations.
Okay.
So first one will be exactly the same thing, 2x minus 3 equals 4. And the second one will be 2x minus 3 equals not 4, but -4. Because absolute value inside can be either the positive or the negative, and then it makes it positive, right?
Mm-hmm.
So I have made the two equations. Absolute value equation, I have made two equations, two simple equations. One is 2x minus 3 equals 4, and the second one is 2x minus 3 equals, if whatever the number, make it negative.
Okay.
Now solving it, adding 3 to both sides. So 2x equals 7, x equals 7/2, adding 3 to both sides. 2x equals -1, x equals -1 divided by 2. Right?
Mm-hmm.
So you got the two values of x which are satisfying this absolute value equation. Let's try it. If you're having 7/2, that means 3.5. Let's plug it in the absolute value equation here. Absolute value of 2 times 3.5 will be 7. 7 minus 3 will be 4. Yeah, 4 is equal to 4.
Okay.
And absolute value of, let us plug in negative 0.5, because negative 1/2 means negative 0.5, right?
Mm-hmm.
So let's plug it in negative 0.5 here. Absolute value of 2 times a negative 0.5 minus 3. So it'll be absolute value of a negative 1 minus 3. It'll be absolute value of negative 4. And absolute value of negative 4 is 4, right?
Mm-hmm.
And 4 is equal to 4. So
Okay.
both these numbers are working. So this will be the way of solving absolute value equation,
Okay.
right?
Yep.
Can you solve for me an equation, absolute value of x minus 3 equals 5? Can you solve it?
That's
Can, can you tell me which numbers are satisfied by this absolute value equation?
it's 5. So you would do. So you would do x minus 3 equals 5, and then x minus 3 equals negative 5.
Correct, yes.
So equals negative 5 and plus 3. Plus 3. That'll be x equals 8, and then minus 3. X equals 8, and then x equals negative 8.
Negative? Can you solve it again? The second one?
Oh, x equals negative 2.
So we got the answers as 8 and negative 2, right?
Mm-hmm.
And that's correct. That's the answer, 8 and negative 2. These two numbers are satisfying this absolute value equation. So till now, it's fine, right? Absolute value
Yep.
equations. Great. Now let us move on to absolute value inequalities. Okay, so this
Okay.
is a little bit, different now. And now let us go to absolute value of x minus 3 is less than equal to 5. Can I hold for a sec?
Mm-hmm.
Okay, 1 second, because my son has came, like he might disturb, so I'll just put him back.
Okay.
Yeah, I'm sorry.
No problem.
Okay, so I'll be giving you, we'll be taking two inequalities in order to understand all the things which are involved in this. Absolute value of x minus 3 is less than equal to 5, and absolute value of x minus 3 is greater than equal to 5. So these are two questions, for example. Now let's try to solve these two questions. Remember some few points here, because that will be used again and again. Whenever you will be having, the less than or equal to inequality, less than equal
Mm-hmm.
to or less than, it's one of those, it's just similar. Less than or less than equal to.
Okay.
Do you know this sign? Less than equal to, greater than
Yes.
equal to.
Yep.
Okay, so if you're having if you're having absolute value inequality involving less than or less than equal to sign, but let us first do without absolute value here. Okay, let's try to
Okay.
first do without absolute value. If you're having absolute value inequality, if you're having inequality, x minus 3 is less than equal to 5, then you will do exactly the same thing as you do for the equations. But one thing you have to remember in inequalities, and that is the very important point, when you will multiply or divide by a negative number, then inequality changes the direction.
Okay.
So if I'm multiplying it with some negative number, this less than equal to will become greater than equal to. Less than will
Okay.
become greater than, or greater than will become less than.
Got it.
So this is the difference between inequalities and equations. In equations, nothing happens. But in case of inequalities, this inequality changes the direction.
Okay.
Now let's
Got it.
solve it. We'll add 3 to both sides as we do for the equations. So x is less than equal to 8, right? Now that means this inequality, x minus 3 is less than equal to 5, it's satisfied by all the values of x, starting from 8, including 8, and going towards the left, towards negative infinity. Am I right?
Yep.
So all these values are the solution for this inequality.
Got it.
But if we'll be having x minus 3 is greater than or equal to 5, then we'll be adding 3 to both sides. We'll be having x is greater than or equal to 8. So it is including 8 and greater than 8. So that means it'll be towards the right side, towards infinity, right? All the values. But if this would have been greater than 8, not greater than equal to, then you are not including 8 as the answer. Then it'll be a hollow circle. It will not be a solid circle.
Oh, yeah. Got it.
Hollow circle, and then towards the right.
Okay.
In the same way, if x is less than 8, then it'll be again hollow circle towards the left.
Okay. So it's only a closed circle when it's equal to.
Yeah, when there'll be equal to, like greater than equal to and less than equal to, then only you'll be having the closed circle. And
Okay.
this will be indicating you that that number is also included in the answers. That number is also included in the solutions, right? So that's why this solid circle is representing that 8 is also included. Hollow circle on 8 represents that 8 is not included.
Okay.
All right, so this was absolute value equations. And but one more example, negative x plus 3 is greater than 7. Can you solve it?
So negative x plus 3 greater than 7, that'll be minus 3. Negative x is 1 divided by negative 1.
How much is 7 minus 3?
4. So that'll be x is less than negative 4.
Correct. Great. Wonderful. Because when you will divide or multiply by a negative number here, you will change the direction of the inequality. So
Okay,
that thing needs to be very much, cleared. So x is less than negative 4, and that is the answer. Correct. Can you graph it? Where should it start?
So you would do 4 and then it would go,
Negative 4, right?
yeah, negative 4, and then it would go like to the left.
Is it a hollow or a solid circle?
It would be hollow.
Correct. And towards the left. You're right. Now let's go to the inequality. Absolute value inequality, sorry. So absolute value of x minus 3 is less than equal to 5. As we did for the equations, we made the two equations, and the same way we'll do it for the inequalities. We'll make the two inequalities.
Okay.
But few points to be remembered here. If the inequality is less than or less than equal to inequality, then those two inequalities will be having an and in between the two.
Okay.
And if the inequality is greater than or greater than equal to inequality, then those two inequalities will be having an or in between the two.
Okay.
Right? So you can write it somewhere. You can make it less than equal to or less than as and, greater than equal to or greater than as or. First thing. And the second thing is you'll make the first inequality same as it is without the absolute value sign. X minus 3 is less than equal to 5, as we did for the equations. But in case of equations, what we were doing for the second equation?
We would do is less than or greater than?
Yeah, but in case of equations, if this would have been 5, we were writing -5, isn't it?
Oh, yeah.
And here also you'll be doing -5, but you'll be changing the direction also.
Okay.
That is it. So in order
Okay.
to write this absolute value inequality, you have to write the first inequality as it is, put an and in between them, and then write the second inequality with the changed sign and the direction.
Okay.
Both are changed, the sign as well as direction of the inequality.
Okay.
And now we can solve it.
Okay. So that would be x minus 3 is greater than or equal to plus 3 plus 3. That would be x is less than or equal to 8.
And
And plus 3 -2. So x is greater than or equal to -2.
now think about what we have done, what we have got. X is less than equal to 8. That means it would have been all the values, including 8, towards the negative infinity, isn't it?
Mm-hmm.
But it's telling you, and there's one more criteria. And the second criteria is that x is greater than equal to -2.
Okay.
So you will take all, if you could have taken all the values of, from -2 to infinity, but you will stop at 8 because it's telling you and both the conditions should be met.
Okay.
So from -2 to 8, that's it.
Okay.
That is the solution for this inequality. All the values from -2 to 8.
Okay.
And these two inequalities, which are having an and in between them, can be represented by one inequality, combined inequality, putting an x at the center. And I know that x has to be greater than or equal to -2. Isn't it? X has to
Yep.
be greater than or equal to -2. And x has to be less than or equal to 8. So x has to be less than or equal to 8. So I can
Yep.
combine these two inequalities and I'll get one inequality. -2 is less than or equal to x and x is less than or equal to 8.
Yep.
We are done.
Okay.
Which option?
Got it. So be A.
Correct. It'll be A. But if the question would have been greater than or equal to 5, then the condition would be different.
Oh, it would be or.
Exactly. It'll be or at the center. And it'll be greater than or equal to here, and then it'll be less than or equal to, but -5.
Okay.
But when you'll solve it, you'll not be able to combine them, right?
Okay.
You'll
Yep.
be getting the value as x is greater than or equal to 8 and x is less than or equal to -2. So that'll be like, greater than or equal to 8. So from 8 towards infinity, or from -2 towards negative infinity. So you'll be taking all the values, excluding the values which are in between -8, which are in between 8 and -2,
Oh, okay. Got
right?
it.
So the opposite of like the previous one.
Okay.
So less than equal to is having a different scenario, and the greater than equal to is having a different scenario, different way of doing it.
Got it.
But sometimes what happens is the question is asked like, if -2 is less than equal to x plus 3 over 4 and less than equal to 20, what is the value of x? So at that time, you have to simply, do whatever you do for the central term, you have to do it for the all terms. Since it is divisible, having divided by 4 and you want to multiply 4 to both sides, you'll multiply 4 to everything throughout.
Oh, okay.
So multiplying by 4 throughout, multiply 4, multiply 4, multiply 4. So it'll be -8 is less than equal to 4 and 4 will cancel out. It'll be x plus 3 is less than equal to 80.
Okay.
Subtracting 3, subtracting 3, subtracting 3. So negative 11 is less than equal to x is less than equal to 77. That's the answer.
Okay, got it.
Great. So this is the way of if the question is in the combined form, like is having some numbers and some other things in multiplication or division or addition in the center, then you will do whatever you want to do, you'll do throughout.
Okay.
Question number 6, option A is the right answer. Okay, we'll go for 7.
Okay.
Can you read it?
The sum of A and B is 132.
1 second. So we'll always try to convert the verbal sentence to a mathematical sentence and write it down. So what should I write?
A plus B equals 132.
Okay.
If A is the square of B, so that'll be
Mhm.
A is the square of B. So
So
that'll be A squared equals B.
A is the
A is the square. Oh, A equals B squared.
right. So A is means is equal to. So A is equal to square of B means B squared. That's it.
Okay.
Okay.
And then the product of A and B is negative. So that'll be A times B is negative.
Right.
What is A?
Any strategy in your mind?
Plug in.
Exactly. Plug in the value of A.
Okay, so
But tell me, if A is B squared, out of A and B, which should be negative?
B.
B, because A is always B squared. So any number which you'll take for B, you'll make it square, and that'll be always positive. So we got one thing, that A is positive and B has to be negative, and we have to calculate the value of A. So A can never be negative, so we can eliminate option A.
Okay.
So we don't need to even check it out. Let us check for A as 11.
So we'll do this.
A.
Oh,
Uh-huh.
could we do 132 minus 11?
Yeah, correct.
So 132 minus 11 would be 121.
Okay.
So A would equal 121.
A would equal
Oh
120.
no, B
Mhm.
B would equal 121.
B will equal 121, and A will be 121 squared, right?
Yep.
And that'll be a big number, and there's no option there.
So it's not 11.
Nope. You have to have, A has to be like B squared. That means A will be a perfect square number. It'll be like either 5 squared or 6 squared or 7 squared or 8 squared, 9 squared, 10 squared, 11 squared. It'll be a perfect square number.
Oh, so it'd be most likely.
Most likely C or D, right?
Yeah.
Because C is also a perfect square number and D is also a perfect square number.
Okay.
So let's try to plug in.
So we could do 132 minus 121.
Mm-hmm.
121, which will equal 10.
Okay. So if B is 10, then A would be.
100.
So there's no option.
Mm.
What about 144?
So 132 minus 144, that'll be.
I think we are doing wrong. We are calculating A, isn't it?
Oh, yes.
So we were doing a little bit wrong here. Let's try to plug in again. If A is 11, if A is 11, then B will be 132 minus 11, right?
Yes.
Or you can say if A is 11, B would be square root of 11, right?
Mm-hmm.
So I'll write it here. If A plus B is 132, and if A is equal to B squared, doesn't that mean when you'll square root it, it'll be b is equal to square root of a. Okay, so now let's plug in which number is working in both the equations. So let's plug in 11. So if a is 11, if a is equal to 11, then it'll be b will be 132 minus 11, that'll be 121. So if it is 121 here, 121 equals square root of a. When you'll square root it, it'll be 121 square is a. So we're not getting a is 11 here, and a is 121 square, so not matching. So 11 is not the answer. Let's go for 121. If a is 121, then b will be 132 minus 121, and that'll be 2 minus 1 is 1, 13 minus 12 is 1. B is 11. B is 11. If b is 11, then a will be b squared. A will be a b squared. So a will be 121. A will be 121. So yeah, I think that's working, right? If a is 120, yeah, because we have got a is 121 and a is 121. So I think option C is the right answer. Can you yourself try option D and check out?
So we would do 144 plus b equals
Mhm.
144. 144 plus b equals 132. So that means 140. So that means b will equal negative 12. So
I have done somewhere wrong. I think option D is the answer.
yeah,
Mhm.
and the negative 12.
So a plus b is 132. A is the square of b, and product of a and b is negative 2. Product of a and b is negative. So a is b squared, or else what you can do. So what you got? Can you tell me again?
I got, so it'll be 144 plus b equals 132. So b would equal negative 12.
Okay, and we need b as negative, right?
Mm-hmm.
And that is only satisfied by option D, because in case of option C, b was positive,
Okay,
right? Because
got
a
it.
times b has to be negative, and that's only possible when b is negative, because a is positive always, right?
Mm-hmm.
So that's why all the criteria, all the conditions are satisfied by option D,
Got it.
right? That is, by plugging in otherwise what students will do, they will plug in the value of a as b squared plus b equals 132, or you can say b squared plus b minus 132 equals 0. It'll be a
Got it.
type of x squared plus x minus 132 equals 0. This will be the quadratic formula, and they'll be solving it by factoring it, or by using the quadratic formula, or by using the calculator if it is in the calculator portion.
Mm-hmm.
So then they'll be getting the values of x something and something, and then that will be the value of b, and if that is the value of b, they'll be getting the value of a by squaring it.
Okay.
Right? Try to do
Got
that
it.
also. Try to do that also when you'll be having time before our next session.
Okay.
Try to see all the questions which we did till now and the concepts and strategies related with that, and move on to the next few questions. Right?
Yes, we'll do.
Because this is a mini test, it will not be having so many questions. It'll be like few of them. So you'll be trying them, all of them, if you get time before our next session.
Okay, I will.
And the answers are also there. So when you will do the questions, after doing them, you can check out the answers and mark those questions which are wrong or which you're confused with.
Okay.
Any questions for today?
Nope. Pretty good.
All right. Thank you very much.
Okay, thank you.
Bye-bye.
Bye-bye.